In SEG version 5.03, we have developed a new feature, give the user the ability to define a shell plate from different pieces and thicknesses with a staggered arrangement. As you can see in this image, we have the flat pattern for the shell, and now we will try to create this by using the new feature. Now let's select the new type of shell, which is shell from random plates. After that, we will add a new child. This child will give you the ability to create those plates and give them the suitable arrangement for your case. Now let's select the first plate. Here let's define this plate. Let's start from 330, okay, and end to 100 degrees. So let's define the location and length for the plate. Okay, so we have the datum line, and now let's define the start and end angle. They should be in the counter on clockwise direction. Now the second plate, let's define the thickness, okay, and the location. Start from 1800, and now let's define the length. The third plate start from 100 degree, okay, up to 150. Now the length of this plate, let's define the length and the thickness. Okay, the fourth plate starts from 15 degrees up to 150. And here the thickness of this plate is 8 millimeters and the length is 800. The location from the datum is 1 meter. Now let's define the next plate. The same thing for each plate, defining the start angle and end angle, and you should take in your consideration that the definition of the angle should be in clockwise direction. Okay, the next angle, let's define the start and end angle, define the length and thickness, define the location. Okay, here we have the length of the plate. Let's calculate it and define it. After that, the location. Start from 220 and end at 260. Define the length and location. Now the last plate. Let's define start and end angle. 260 and 330. The length and location at 200. Now let's click save and start creating this shell plate. As you can see here, you can create this shell from staggered plates as mentioned on the 2D drawing. Something like that is very difficult if you would like to create it by hand, but with SEG you can generate that easily. Here you can generate your bill of material in seconds and you will get a detailed bill of material for the shell plates with actual lengths for plates. In SEG version 5.03, you can generate an eccentric and eccentric reducer from staggered or random plates. Now let's add eccentric reducer from random plates. After that, you have the ability to add a child as random plates. Now let's define the first plate thickness, first plate length, location, start and end angle, and take in your consideration the start and end angle should be in clockwise direction. Now let's define the third plate, thickness, location, start angle, end angle, and let's add another plate, thickness, length, location, start and end angle. Let's define the dimensions of another plate. After adding all of your plates, you can run the assembly to generate the 3D model of this eccentric reducer from random plate arrangement. Now let's run the assembly. Now as you can see, you have this reducer from staggered blades. It's a very complicated shape, but with SEG software you can generate that in minutes. Now you will get a detailed and complete bill of material for this reducer. With SEG version 5.03 you can generate a flat head or a flat bottom for tank from random blade arrangement. Now let's add a flat head. Okay, and from here let's move it before the shell, can 1. So now let's select the last type for heads. After that, let's add a child which give us the ability to define each blade separately. Now we have the first blade with the thickness 10 millimeters, and here let's define the length and width as per this image. As you can see, the location or the datum point located at the top on the right hand side, and the location for the reference point for the blade, you can define it as per the image on the right hand side. After that, define the length on X direction and the width of the blade on the Y direction. Now let's define the third blade. Define the location or the length and width. After that, the location in X and Y. Let's add the fourth blade. Define the thickness and the length of this one, which is 1700 minus 90. Okay, that's the length of the blade. After that, define the width and the location from the reference point in X and Y direction. Now let's define the last blade. We have the length to define the length of the blade in X direction and the width in Y direction. After that, let's generate the 3D model for this flat head from random blades. Now we get the same configuration that we have on our sketch. Now one more option, you can control the orientation of the blades. So if you change the orientation to 45 degrees and update your model, as you can see, you can rotate all blades to 45 degrees from the data point. And you can get a detailed bill of material for this head. As you can see, you will get the length and width, the actual dimensions for length and width in detail. With SEG version 5.03, you can generate internal ladders inside the shell. You have 4 types of the internal ladders. The first 2 types across the shell on the circumference direction. You can make the main sides of the ladder from equal angles or from blades. That's the first 2 types. As you can see, if we take a half section or a section with the circumference direction, as you can see, it's across the diameter of the vessel. Now let's add another type for the ladder. We have type number 3 and type number 4, type C and D. They are along the shell. Okay, and you can make it the sides from equal angles or from blade. As you can see here, the difference between the first 2 types and the second 2 types. And here you can see you can make the ladder from equal angles or from blades, like that. And by the way, you can flip the direction of the ladder type C and type D. to make them on the other direction if you would like to flip the direction of the letter by that way, by using the other side option. Now with SEG version 5.03 you can add a coil to centric or eccentric reducers. Now if you select the centric reducer, which created from random plates, now you can add a coil to it by defining the dimensions as per the attached image on the right hand side. Now you can generate this coil along the eccentric reducer. And besides that, you can add attachment to the two ends of this reducer, like adding a pipe to one of those ends. After that, adding a flange to this pipe at the end of this pipe, defining the flange to be a slip-on flange. Now let's add another pipe and make it same as the previous pipe, another flange to the second exit. And now let's run the assembly. As you can see, you have the ability to add a piping connection to the end of the coil. With SEG version 5.03, now you can add a coil to the head with crown and nut radius. You will find two main types for the coils. The first type defined the spacing along the straight flange, equal spacing, and the second type which we will create with the equal pitch from the top view. Now let's generate this coil and add a connection to the ends of this coil, like two elbows, and define the orientation of each elbow at the end. And now after generating the 3D model for this coil with two connected elbows, as you can see, you can make a coil at the top of the head by that way. Now with SEG version 5.03, we update the cross beam feature to make it include a wear plate in the two sides. Now, for example, if you select this type of cross beam, you will find an option to add a wear plate. Now let's define the location and some other dimensions. Now let's run the assembly and you can figure that you have two wear plates along the cross beam. And you can rotate the cross beam around the axial orientation. So let's change it to 0 instead of 90 degrees. And now let's run the assembly to update the orientation of the cross beam. With SEG version 5.03, you can generate a Y joint connected to a hemispherical head with negative straight flange. Now let's add a hemispherical head with negative straight flange. Let's keep all dimensions as they are. And now let's add a Y joint, but that time let's select the second type which is connected to a hemispherical head. Now let's define the dimensions as per the attached drawing. The height, the side diameter, thickness, the fillet and the radius, all dimensions of this Y joint connection, the head and side diameter. So let's calculate it because we have the radius, the head thickness, and the straight flange, which is the value of the negative straight flange of this head. Now let's run the assembly, and as you can see, during the generation of the 3D model, the head is not with a correct dimension. Now let's open the Y joint connection and get the right values and put it here in the head with negative straight flange. And now let's update the model to correct the dimensions of this head. Now let's take a section and check out the dimension. Everything is okay now after modifying the head dimensions based on the Y joint. Now in SEG Software version 5.03, we have developed a new feature for the JIS5 standards. We have three different categories. The first category defined by nominal diameter and scalable. So you can select the suitable standard. After that, select the size, and after that, the scale. The second category is defined by nominal diameter and thickness. So you can select the standard. After that, select the diameter and thickness. The third category defined by outside diameter and thickness. Okay, so you can select the standard from the list. After that, select the size and thickness. Now let's create this one and add an external ladder for this pipe. And you will find that we have two different types of external ladders. One of them include equal angles as the sides of the vertical ladder, and the second type with plates. So the sides of the ladder will be created from plate. Here, as you can see, in that type, the ladder sides from equal angle, and here you have a cage for this ladder. You have the ability to add a cage and a base plate for the ladder with a fixed hole.